welcome to yet another lecture on the chapter hydrogen. So last day we looked into the position of hydrogen in the periodic table, the isotopes of hydrogen, the occurrence of hydrogen, and also the preparation of hydrogen. Today we will be looking into the properties of dihydrogen. So without wasting further time, let's get started. We know there are two kinds of properties, physical and chemical. Firstly, we'll be looking into the physical properties of hydrogen. So firstly, the most important thing is hydrogen is colorless. That is, hydrogen does not have any kind of color. Secondly, hydrogen is odorless. We do not find any kind of odor or smell from hydrogen. Thirdly, hydrogen is tasteless. There is no kind of taste in hydrogen. I won't suggest you to taste and check this because it is dangerous.
कुछ भी
Fourthly, hydrogen is a combustible gas, which is very important to remember. When in contact with oxygen, it might turn into flames and fire, which is very dangerous. Then fifthly, hydrogen is lighter than air. Air, as we know, is very light and hydrogen is even lighter than that. Now imagine how light it is. And most important thing is hydrogen is insoluble in water. It is not soluble in water. It cannot be dissolved into water. Okay. So these are the physical properties. Remember them. Now we'll be moving into the chemical properties of hydrogen. Chemical properties. The chemical behavior of hydrogen or any molecule, is mainly determined by the bond dissociation enthalpy. Now, what do I mean by the bond dissociation enthalpy? Bond dissociation enthalpy means the single bond between two hydrogen atoms. It could have been any other molecule since this chapter is all about hydrogen. So, I have taken the bond between two hydrogen atoms. So the energy that is required to break this single bond present between two hydrogen atoms is referred to as the bond dissociation enthalpy. The energy or enthalpy that is needed to break this single bond, Bond dissociation enthalpy. Remember this, that this determines the chemical behavior of any molecule, but over here since we are talking about hydrogen, so hydrogen. These are the two hydrogen atoms and now the bond is broken using bond dissociation enthalpy. Now the most important point to remember is bond dissociation enthalpy is highest in case of hydrogen for a single bond between two atoms, This is highest in case of hydrogen. We'll be looking into the values. I have written the values down. You don't need to remember the values, but still 0.081%, which is around 2000 Kelvin. Imagine how high the temperature is, and it increases to 95.5%, which is at 5000 Kelvin, Now we come to a very important point, which is hydrogen is relatively inert at room temperature, Relatively inert at room temperature. Room temperature is 32 to 33 degrees Celsius due to its high bond dissociation enthalpy. I have written this in short form, but this is high bond dissociation enthalpy. It is inert at room temperature due to its high bond dissociation enthalpy. Therefore, atomic hydrogen is relatively inert at room temperature due to its high bond dissociation enthalpy, and therefore atomic hydrogen is produced at a high temperature. Okay. Room temperature. So room temperature is approximately 32 to 33 degrees Celsius. Okay. So it is inert at this temperature because it has very high bond dissociation enthalpy, and hence atomic hydrogen is produced at very high temperatures in an electric arc or under the presence of ultraviolet rays. Okay. Because these have conditions of very high temperature. Since its orbital is incomplete with 1s1 electronic configuration, we know that hydrogen has an electronic configuration of 1s1. If it would have been 1s2, it would have been a complete orbital, and hence to complete this orbital structure, it does combine with almost all the elements present. Okay. So basically we can categorize the reactions of hydrogen in three ways, like how does hydrogen accomplish reactions. Okay. Firstly, by loss of one electron. By the loss of one electron, hydrogen results into unipositive H. So H plus. Okay. Then by the gain of one electron, so uni-negative H minus. And finally, by another method, which is sharing of electron to form a single covalent bond. Okay. So electrons are shared to form a single covalent bond. Now we look into the reactions of hydrogen with various elements and compounds. Firstly, the reaction of hydrogen with halogens. So H2 in the form of gas plus X2 in the form of gas will result in the formation of 2H plus. 2HX, okay? And X is maybe fluorine, chlorine, bromine or iodine. So hydrogen plus X2 will result in the formation of 2HX. X may be fluorine, chlorine, bromine, iodine, which are the halogens. Let's look into a reaction. Suppose X2 is F2 and H2 plus fluorine will result in the formation of 2HF, hydrogen fluoride. These are in the form of gas. Okay. H2, this line, the reactivity decreases, okay, from fluorine to iodine. Hence, fluorine may react with hydrogen even in a dark room, while when the reaction takes place with iodine, there is a catalyst required since reactivity decreases. Okay. Now we'll be looking into the reaction of hydrogen with dioxygen. It is highly exothermic reaction. Keep this in mind. Highly exothermic reaction means there is high amount of energy which is released. So H2 hydrogen, which is in the form of gas, on reaction with oxygen, which is in the form of gas in presence of catalyst or heating, results in the formation of water, which is in the form of liquid. Okay. These are in the form of gas and there is a catalyst or heating must be present and we get water as the final product. Delta H minus, I have given the value, it is minus 285.9 kilojoule per mole. Okay. Per mole. You may remember this value or may not remember this value. Just remember that it is a highly exothermic reaction. High amount of energy is released. Okay. Now reaction with dinitrogen. Hydrogen in the form of gas on reaction with nitrogen in the form of gas at 673 Kelvin, 200 atmospheric pressure, in presence of iron as a catalyst, will result, iron is a catalyst, okay, will result in the formation of ammonia gas. Ammonia in the form of gas, okay. And this method is known as Haber's process. It is a very important process because ammonia has a high commercial value and we can produce high amounts of ammonia through this process. Remember the conditions: 673 Kelvin, 200 atmospheric pressure, and iron as a catalyst. This is a very important reaction. Keep this in mind, okay. We get ammonia in the form of gas, and this is Haber's process. And I have given the value of delta H minus. You may or may not remember this. Okay, this is minus 92.6 kilojoule per mole. Now we'll be looking into the reaction with metals. Reaction of dihydrogen with metals. So hydrogen combines with many metals at high temperature to yield corresponding hydrides. Okay, combines with many metals at high temperature. Remember, high temperature is required, and we get hydrides of the corresponding metals. The metal with which hydrogen combines, we get hydrides of that metal itself. So H2 in the form of gas plus 2M, means M represents the metals, will give 2MH, the metal hydride, which is in the form of solid. M is any alkali metal, okay. So let's take an example of alkali metal. Let's take up sodium, which is represented by Na. So Na, we have taken sodium. To balance it, we take 2, it is written as 2M, so we take 2Na. M is Na over here, plus H2 dihydrogen, both in the form of gas, will result in the formation of 2NaH. Here in place of M, we put Na. Okay, so 2NaH, which is the metal hydride in form of solid. Now we'll be looking into the reaction of hydrogen with metal ions and metal oxides. So hydrogen reduces some metal ions in aqueous solution. Metal ions reduces them, and oxides of metals which are less active as compared to iron. Okay. It reduces metal ions and also reduces oxides of metals to their corresponding oxides. Means oxides of the same metal. Oxides corresponding to the same metal. Less active than iron. Metals less active than iron. So if you look into the metal reactivity series, where reactivity decreases down the line, first comes potassium, then sodium, then calcium, then magnesium. In this way it decreases down the line, reactivity. Then after a few elements comes iron, okay. Then after iron there comes a list of another elements. So here it is written that elements less reactive than iron means elements which are written below iron in the metal reactivity series, okay. The corresponding oxides of the metals which are less active than iron, okay. Into the reaction we find hydrogen on reaction with Pd2 plus gives Pd, which is in the form of solid, and 2H plus, which is aqueous, okay. Now another reaction is YH2, which is in the form of gas, plus MXOY, which is metal oxide in form of solid, will result in the formation of XM, which is solid, which is metal, plus YH2, which is liquid. So earlier it was palladium 2 plus, which when on reduction gives Pt. It was 2 plus oxidation state and then 0 oxidation state, and here the metal oxide gets reduced to metal and then we get water in its liquid form. Now we look into the reaction of hydrogen with organic compounds. So hydrogen on reaction with organic compound, I have written that in short COMP, which means compound, in presence of a catalyst will give the final product as hydrogenated product, okay, which is very useful in the commercial market. So, hydrogenation of vegetable oils in presence of catalyst, we get the hydrogenated product, which we'll be looking into. So hydrogenation of vegetable oils using nickel catalyst will result into the formation of edible fats, which is, for example, margarine and vanaspati ghee. Then we look into the hydroformylation of olefins. Okay, so olefins on hydroformylation result into the formation of aldehydes, and the aldehydes on reduction gives us alcohol. Okay, so let's look into the reaction, how this takes place. Hydrogen on reaction with carbon monoxide plus RCH double bond CH2 will result in the formation of aldehyde, which is RCH2CH2CHO, and again hydrogen on reaction with this aldehyde, which was RCH2CH2CHO from the previous reaction, will result in the formation of alcohol, which is RCH2CH2CH2OH. Okay, so this is the alcohol and this is the aldehyde which we got in the previous reaction. Now the reactions are over. Now we'll be looking into the uses of hydrogen. Okay, so hydrogen has multiple uses. Firstly, in manufacture of metal hydrides. We looked into the reaction earlier, how sodium hydride was formed on reaction of sodium with hydrogen. Similarly, other metals too on reaction with hydrogen gives us metal hydrides, which is commercially very important. Next is synthesis of ammonia. We looked into the process which is known as Haber's process. Ammonia is very important for commercial reasons because it is used in a manufacture of nitric acid and fertilizers rich in nitrogen. Hence the formation of ammonia with the help of hydrogen is very important. Nitric acid is a very important chemical. It is used for various methods, and fertilizers are important for plants. Fertilizers rich in nitrogen help in plant growth. Next we come to another use. It is used as rocket fuel in space research organizations. It's a very important fuel in rockets. Next is manufacture of vanaspati fat by hydrogenation of polyunsaturated vegetable oils such as soybean and cottonseed oil, etc. We looked into the reaction earlier. This is how hydrogenation of vegetable oils in presence of nickel catalyst results in the formation of edible fats such as margarine and vanaspati ghee. Okay. Now we come to another very important usage, which is preparation of HCl. HCl is highly used in various fields, industrial and other purposes too. The next usage of hydrogen is in reducing heavy metals to metal oxides. We looked into this too earlier. One is manufacture of metal hydrides and another is heavy metals getting reduced to metal oxides in presence of hydrogen. The next usage of hydrogen is manufacture bulk organic chemicals, mainly methanol. So hydrogen is used to manufacture organic chemicals in bulk. Usually it is methanol. We see carbon monoxide in form of gas plus hydrogen in form of gas in presence of cobalt catalyst will result in the formation of methanol, which is liquid, which is in liquid state, and it is very important for commercial purposes. Next is fuel cells. Hydrogen is used in fuel cells for generating electrical energy. Unlike fossil fuels, it causes no pollution. Okay. And greater energy per unit mass of fossil fuel. Greater energy per unit mass of fuel is used in comparison to gasoline, etc. So hydrogen is used in fuel cells for generating electrical energy, and no pollution takes place. Unlike when fossil fuels are used, there is a great deal of pollution which takes place, and greater energy per unit mass of fuel is used in comparison to gasoline and other things, etc. And finally, most important use is atomic hydrogen and oxyhydrogen torches are used for cutting and welding purposes, which are used in various metallurgical purposes. So the atomic hydrogen is basically produced by dissociation of dihydrogen with the help of electric arc, where very high temperatures are present. Earlier we said that bond dissociation enthalpy of hydrogen is very high. So for cutting and welding in metallurgical purposes, an atomic hydrogen recombines on the surface to be welded to generate a temperature of 4000 Kelvin, which is very high temperature. Okay. So this is all for today. These were the uses of dihydrogen that we looked into. We also saw the various chemical properties of dihydrogen, the reactions of dihydrogen with metals, metal ions, nitrogen, oxygen, organic compounds, halogens, all the various reactions. We saw how hydrogen accomplishes reactions. We saw various important points, the chemical properties of hydrogen. And firstly, we did see the physical properties of hydrogen. So this is all for today. Thank you, take care, do like and share this video and subscribe to our channel, and do study properly.